Hi, everyone. Thanks for joining us this morning or afternoon, depending on where you are. This is the Measuring What Matters webinar, which is an intro to evals. My name is Carlos. I'm a solutions engineer here at Braintrust. And today we're just going to talk about why you should be evaling, what the process looks like, and what the benefits you can gain are. Cool. So starting sort of high level with the question of, why even eval? Well, really, it's because they help you answer questions. And the reason why these questions are so important is because the nature of AI is non-deterministic, right? These are stochastic systems. You give them the same question, there's some randomness in the response. And so you need to have a statistical way, like a process that gives you confidence so that when you make a change, it's not going to lead to a regression. You need to have a process in place so that you can catch hallucinations and build an agent that has consistency and can provide the best user experience possible. There's other questions that are really important as well, like which LLM model should I be using? Is it the most cost efficient, or is it actually performing the best, right? How do I know when something breaks? Where do I look to see it? Um, you know, if I'm capturing feedback from my end user, am I able to actually act on it and integrate it into my development process and improve my agent's performance? So all these questions, I think we all understand are really important to solve, and having a process like evals can really help the team at large within your organization start tackling them. So what is an eval? I think when I first heard this term, I was like, what does that even mean? What are we evaluating? What is this? And I think really what you need to understand is there's three ingredients that go into an eval. So starting from the left, there's what we call the task. And this is the thing that you're evaluating, right? This is the subject of the eval. Uh, Typically, it'll be a system prompt, but it could be as complex as you like. It could be a chain of prompts. It could be a full agent. Really, it's up to you. All it requires is an input and an output. And what you'll be doing with the eval process is you'll be iterating on that task. You'll be making a change to the system prompt, to the agent, and you'll be seeing how that downstream affects the scores, right? In order to understand how the task is performing, though, you need to have a data set. And this data set contains a lot of real world examples of how your end users will be interacting with your Gen AI application. So this is something that you'll want to really invest in covering as wide of a range as possible. There's a lot of edge cases that you don't have the vision to see it when you first start a project. So your data set will evolve with you. And then finally, you have your set of scores. So this is the actual logic behind the eval. You could think of this as the code behind a unit test, but here it's a little bit more abstract. So you can use code scores, right? You can use actual code that's deterministic. This is super effective, but it doesn't really solve some of the more subjective, qualitative checks that you'll want to do on your agent. And so that's where you have the LLM as a judge come in. But really, this is the backbone of the eval. This is how you're defining what you care about, what you want to measure. And a big difference here is they're not necessarily pass fail. They're on a range of 0 to 100. So each score will return a value between 0 and 1. It's a percentage, and that gives you flexibility on how you analyze and how you gather insights from your evals. So starting with the data set, that's probably the first thing that you'll want to do is define what are my end users going to be asking of this agent, of this feature. And you want to start small. Really, the goal is to get to the eval phase as fast as possible, because it'll show off where your weaknesses are in the product, and it'll lead to actions that will increase your performance. So it can be very, very effective to eval, and the friction is starting. And so if you can just have 5-10 examples that represent one persona, maybe the main persona of your product, and then from there you'll keep enhancing it. And something that's crucial to the the process of enhancing your data set is using production examples. And so if you have a tool like Braintrust where your evals and your observability into production is in the same place, it's very easy to have a flywheel where you grab those production examples and you feed them back into a data set. So as your users report certain issues, as you start noticing that there's been regressions or there's been, you know, latency goes up, any sort of issue like that, you can use those examples and add them back into your data set. And over time, this will scale. You'll end up with hundreds of cases. And oftentimes you hear the term golden data set. And this is what you would want to run anytime you make a change to production. So before it gets to production, you would run it on that golden data set. And that would prevent playing whack-a-mole, right? You'd have a comprehensive coverage of all the ways your users will interact with your product. Zooming into scores a little bit more. So we talked a bit about code scores versus LLM judge scores. So code is what you'd want to initially start with. They're cheaper in the sense that you always know that a certain output is going to come out the other end. If you have, you know, an engineering team, they're very fluent in these code scores, very much like unit tests. And this can be great for the quantitative side of the eval, right? But this isn't going to cover everything that you care about in the final response of the agent. And so that's where you need to rely on another LLM. So you're using non-determinism to grade non-determinism, which may seem a little counterintuitive, but it can actually be really effective. And this is because it can tackle those subjective or human-like interpretations of the response. And so you'll be defining a prompt for that LLM judge that will then be grading the output of your task. And something that's really crucial is the same way that you're evaluating your task prompt or your task agent, you'll want to evaluate your LLM judge and make sure that it's aligned to what a human would think when it's also grading those outputs. So as long as you have that human alignment, then the LLM judge can help you scale your evals. And instead of manually reviewing, you can now trust and rely on your LLM judge. Cool. So moving into some of the best practices that we see out in the field, something that's really important is defining success before you start building. Oftentimes we see teams that will kick off an MVP of their project. They don't really articulate the requirements that they need, and it leads to going back to the whiteboard and restarting the process. So if you can be really clear upfront with what you're looking for, this will make the rest of your evals really easy. So if you define that clarity, you define what your success metrics are, it will then lead to a clear improvement target. If you know what you want to achieve, it's a lot easier to see the path to get there. And this will actually bridge the gap between the product team and the engineering team, because the product team we found has been really successful in defining the success criteria. It's ultimately a product decision, very similar to a PRD, while the engineers are in charge of implementing that and making sure that you're ingesting all of the production data into a tool like Braintrust and making sure that evals are set up for the rest of the team to then go in and kick them off on their own. I also want to say that feel free to ask any questions into the chat. At the end of the session, we'll be covering the Q&A. And this slide section is going to end pretty soon. I'm going to jump into the actual platform and show you how you can use the tool. So talking about the evaluation strategy that we typically see, we would recommend for you to start as broad as possible. So more on the end-to-end side of things, where you're letting the agent or the workflow run on its own and you're evaluating the final output. So you're asking, did the agent accomplish its goal? This is very broad. It can actually solve lots of your problems. But as you get to more complexity and you have more intermediate steps, you're not going to be able to pin down the root cause of the issue when you find it, right? And so that's when you need to incorporate single turn evals, or you can think of this as step-by-step evals, where you're asking, was this the right tool call? Were these the correct arguments? And by evaluating at each step along the way to the final response, you can actually pinpoint what caused the error and then take the action to fix it. And this can keep funneling down and getting more and more granular, where you're determining, was the output of the tool call, was it actually used in the final response? So you can sort of get more and more specific with what you want to evaluate in the process, in the long running agent that you may be using, or workflow. When it comes to writing effective scores, there's a few best practices that I can offer. The most important one, I'd say, is to have it be one dimensional, meaning you want to have just one criteria that it's going to be grading and judging, right? You don't want it to do factuality, conciseness, tone all in one. It'll confuse the LLM most likely, and it'll also confuse the human that needs to review it, right? So if you're going and reviewing the LLM judge outputs and needing to determine, was it correct? Do I agree? All of that can get a lot more convoluted and confusing if it's across 5 different criteria, right? So start with one, and when you decide how you want the score to grade it, how many options you want to give between 0 and 1, we would recommend to start binary. So just start pass fail, 0 and 1, right? If the threshold for that criteria is met, then it's a 1. If not, it should be a 0. And that will make your life as a reviewer, as the human overseeing this process, a lot easier. When you are defining that threshold, that bar for pass, you should keep in mind that these are not going to be 100% passing, right? If that is the case, you're not setting the bar high enough. So make them harsh. Make it so that you're actually, failing the evals, especially initially. If you're passing them, it's a sign that you're not going down the correct path. You're not actually looking at the dimensions of the response that you should be grading. And so, just something to keep in mind of, if the scores are low, it's actually okay. And then finally is using that production feedback. So as you're gathering all of that context, all of that signal in your logs, you want to actually loop that back in and incorporate that into its own score. So if you find a pattern in your logs of something that's going wrong, then it should be a light bulb moment to add it to its own score. So an example of this would be a support chatbot. You'd want to measure different dimensions. So factuality, right? Does it answer the correct question? That would be its own dimension. Tone, that would be its own score, right? If it stays under a certain token limit, so in a way, conciseness, you could do that with code, right? And that would be its own score. If it follows the correct format, right? All of these different characteristics that you would want to make sure are happening in the final response, you would add as its own separate score. If we zoom out and we look at the whole development process, you start with your app, right? As you're developing, you'll probably be doing evals to gather confidence. But if not, oftentimes you see people directly go to logs. Maybe they're using the application internally and gathering feedback that way. You can take those logs and streamline them directly to datasets, right? So it's very easy to take logs, add to datasets, and then feed those down into evals. And so there starts to form 2 different feedback loops or flywheel effects, right? You have your evals to loop. So you go evals to iterate, right? You change your system prompt, you run the experiment, you get the scores, and you keep changing and changing. And then you have a larger loop, which is, as you move into production, you can then capture user feedback, add it to your data set, and then that will feed your evals and all the way around into production again. So this is very important to understand sort of how all these pieces fit together and how you can use this all the way into production. Cool. So what we've been seeing from successful teams is to start simple. I think that's made it pretty clear, is just get started. If you have just one score, that's fine. You can expand them. If you have just 5, 10 test cases, that's okay. I would say the most important piece here is to make evals part of your process. So really invest in that workflow so that when you see a user complain in any channel, right, you'll be able to add it to a data set, right? So everything is centralized in one place. It's easy to complete that flywheel. On the other side, right, maybe a new model provider released, a new model, which happens every few weeks, it feels like. You'll want to be able to run the evals very quickly. So have that process in place so that when a model drops, run these evals, and that way you have insights on whether or not you should be using it in production. We have some customers that are able to adopt a new model within 24 hours, which I think it's a very high bar, but something that lots of teams out there should be shooting for. Um, and then as you think of an idea to your product of a new feature, right? You want to make sure that you can validate that with evals. So investing in a CI pipeline, making this as automated as possible is something that we see a lot of teams do. From there, you want to optimize the whole system. So it's not just about prompts, it's about all the intermediate steps. Anything that is dependent and will lead to the final response, you want to optimize and treat as part of your eval. And then finally, I think the last one is about, in a way, humility. Like, embrace noise. It's okay for data to be imperfect. This is a difficult problem. Like, evals are really hard. I would say that's probably, if there's one thing you take away, it's that evals are hard. Your scores are going to be approximations, and that's okay. It's all about iterating and measuring as you iterate. Great. So now that we covered some of the slides and the concepts, we can see how all of these things fit together. So again, it's the data set, the scores, and the prompt. All of that comes into an eval. So let's jump into the platform, and we can see how this works in practice. So the idea that I had last week for this webinar was, let's create an agent that will help me learn more about science. I'm pretty interested in science, and there's a lot of interesting figures in history. And when you hear about them, it's really just about their discovery, right? But I wanted to have more of a human lens and see what they were going through when they came up with that, revolutionary idea or product or whatever. So that's what this agent is going to be trying to do. And so to do that, I'm going to first start with a data set. So here I'm going to define those example test cases. So I'll create a new one for the sake of the demo here. We can drag and drop CSV, JSON files, insert data programmatically, or just create a row manually. I'm going to start with something. So let's go in and grab this JSON file. It has some, sort of more basic examples. So tell me about Mary Curie discovering radium. What was Darwin's emotional state when publishing Origin of Species? So, the sort of the ideal persona that's interested in that type of stuff. These are the questions they'll be asking. And then I also have some assertions. So under the expected column, I'm also going to be establishing some ground truth. So just to sort of pause here and explain, a data set has 3 columns. Input is the only one that's required, right? So that's your actual test case. Expected you can use for ground truth. And then metadata, this becomes a flex column. So it can be used for any additional context that you want. Metadata will be used to inject into your prompt, and it can also be used into the score, whereas expected, it'll be typically just for the score, and then input will be for prompt and the score as well. So we'll see this in practice, but just want to sort of let you know sort of the differences here. Great. So now that I have my data set in Braintrust, there's just actually something really interesting that I can do. So as we've heard, right, 5 to 10 data set rows, that's great. It gets you started. But what if I wanted to dynamically generate more? So we have loop in the top right, and this can actually synthetically generate that data. So let's click that out of the box prompt, and it'll create 5 more rows based on what it sees currently in the data set. So it'll understand the underlying pattern of how the schema is structured, and then it'll go in and create that data. If you wanted to do this at scale, you could. So you could change this 5 to be 50, 100. it'll just batch them out in 10. But definitely something that I've seen customers out there do, especially when bootstrapping an eval for a new project. Great. So I just created these 5 new rows. Super exciting. So yeah, you could sort of envision how this can scale even more. But now that I have a data set, let's go and create a score, right? So what is the thing that I want to measure? What is the thing that I immediately care about? I think the basic example that I want to show you is using the ground truth in the data set. So in a way, an assertion judge. So let's name this assertion. Um, I'll choose the model here. So all of this is using your own API keys, uh, using your own models. All of that can be configured in your settings. I'll be using Claude 4 Sonnet. And then let's define this score. So consider the following question, and this will be the input column of the data set, right? So that's where the question lives. We're using mustache syntax here. And then we're saying, and consider the answer. And this answer is going to be in output. And this is what's going to be generated, right? So when the eval starts running, it'll actually be in its own column called output. And that's how we reference it here. And then I'll say, does the answer satisfy each of the following assertions? Meticulously check each one and write out your reasoning in the rationale section. You don't really even need to say this. This will be automatically done for you. We have the way of managing that using structured outputs. Either way, the rationale section comes with LM judges if you turn on chain of thought here. So now I need to access the assertions, and that's in the expected column, but it's actually under an object called assertion. So I can use dot notation to access that underlying field. And then here I want to give it some options. So you can think of this as a rubric. If you can remember back to college and TAs grading your work, this is essentially what you're doing as well for the LLM outputs. So you're going to be giving the multiple choice each of these. So option A, it correctly satisfies every assertion. We can map this to a score of 100. Option B, since that's some of the assertions, we can say 0.5. And then C, since that's none, we can say 0. Great. And so this is the first score that we've made. You can also see that you can, in the UI, add TypeScript and Python scores as well. I'll save this as a custom score though. And now that we have a data set and a score, now we need to create a prompt. So I'll name this, basic prompt. Let's use this small little guy here. Actually, we can compare them later on, but let's grab this initial prompt I have. So sort of very basic, but here I'm stating, you're a science historian who explains discoveries by focusing on the human side, the emotions, hopes, and dreams of scientists, answer questions while making history engaging and accessible. So we'll save this. And now that we have all of our ingredients for the eval, we can bring it into a playground. So this is a full eval environment that's interactive, right? So here I can grab a task, which in my case is a prompt. So I'll grab that one we just created. Something that I forgot actually is I need to inject the data set into it. So all reference input, once I select this data set, it will actually fix itself. Cool. So the input column will be added here. Boom. And then we can save this as a new version. Great. And then we could see the past version here as well. Nice. So now that we have the data set and the prompt, let's grab that score that we made. And then we can run this. Nice. So it's doing all of this in parallel, creating all of these outputs for the data set, and then it's grading using that assertion judge that we made. Here I can actually add the expected column so we can see what those assertions are. And if I wanted to visualize this in a different way, there's a few other options. So we have list view, and then we also have summary view where we can see the assertion score here. Going back to grid. So I could click into this cell in the playground and we can actually see that assertion judge. And if we wanted to see the underlying rationale, we could go under metadata, and here it explains, each of the assertions that we have in our data set. It's going to explain whether or not it suffices. So since it chose B, we can see here that there was one, or there were actually two that were no. So we got 3 out of 5 assertions. So some were included, but not all. Great. So this is sort of, you just saw how to run your first eval. I hope that was straightforward, makes sense, and something that you could replicate at home. From here, I wanted to show a few different things that you could do. So we mentioned, right, that you could create code scores. I don't really want to write any code, so I'm going to use loop, and this can actually generate some of those code scores for us. So I'm going to grab this prompt I have here. So I'll say, create a Python code score to measure if there are scientist quotes in the output. Have it differentiate between typing actual quotes versus contradictions and apostrophes. So, if I want this to be as factual as possible, I probably need to have some quotes from the actual scientist. So I'm going to create this Python code score to see if it can measure that. Great. So we can see that it created the Python code. I'll accept it. And the reason that it's able to do that is because Loop has a bunch of tools available to it. So it can actually grab the context contained in the playground. So it's a great sidekick as you're running evals, as you're bootstrapping them more than anything, right? It can actually help you create those assets that you need, those scores, so that you can then go later on and start optimizing your prompts. Great. So I can sort of rerun this, and now it'll use that additional score that was created. While that's going, let's see if I can get it to create me another one. So now I want it to be an LLM judge. So I'll say create another score for conciseness. It needs to be short and not say I'll help you explore the fascinating story, blah, blah, blah. Use an LLM judge score. Before or while this works, something that you can also do in Braintrust is add external tools. So this use case would benefit a lot from having a way to retrieve documents, right? So we can learn more about the scientists and the history behind the questions that the user is asking. So you can actually push those tools that you've defined in code, you can push them up to Braintrust with their own custom packages as well. So I've done that here. So I can go and select a get scientist bio tool. We'll set this to be auto and then save this. Cool. So now it created this LLM judge for conciseness. I'll accept this. So now we have 3 different scores. And now it'll actually be using that RAG retrieval step before completing the answer. So let's run this. And we can see that it's running the tool get scientist bio. So yeah, these look to be pretty long, not very concise, I do have to say. Let's see what the scores come back as. Yeah, looks like it needs some work on that conciseness dimension there. So if we click into one of these cells, we'll be able to see that full path that was taken. So if we click into that tool call, we can actually see the context that were retrieved. So it went and grabbed for Richard Feynman, and it was able to actually grab some biographical context here, and actually had some emotional context as well on what his life was like and sort of what he was thinking and up to. Cool. So, now that we see that we have this one dimension that really needs some work, conciseness, what I'm going to do is I'm going to duplicate this prompt. So we now have two side-by-side prompts, and I'm going to ask Loop, I'm going to say, hey, can you optimize the prompt for conciseness? And we can just sort of see how this kicks off. So it grabbed the summary, and it can actually see sort of what's happening, and it'll start now suggesting changes. Explain discoveries concisely, highlighting the scientist's emotions and motivations. Cool. So, we can accept this. So this one I actually want to skip. I wanted to just keep changing one of the prompts, and then we can treat the other one as that B test. All right, so it'll want to rerun the evaluation and see how those scores change. And all of this is, again, being done because of these tools. So we can get the summarized results. What it just did is it ran that eval. It's been creating some of these code scores, LLM judge scores, all of that. Great. So it ran that eval. And so from there, it can then understand the patterns. So it improved a little bit, 180%, it says, by adding some of this. Let's keep enhancing. We'll just give another pass at this. But this is something that I definitely recommend as you're starting out with evals and wanting to do some prompt optimization. It can be super helpful to have an agent alongside with you, speeds up the process, makes it more approachable for people that are new to the platform. I think evals in general, like I said, they're really hard. It's really hard to define these dimensions and to get clarity into what's going wrong. And if you can lower that bar and start democratizing and allowing more and more people, more personas in your organization to run these evals, what we've seen is the effects can be really, really beneficial. So I accepted that additional change that it made. And now let's run these evals. And so what's going to happen now is, we have two prompts pulled in. And it's going to be comparing them, or we can compare them, and then we can even ask Loop, like, which one is performing best, if it doesn't automatically give us those insights. Nice. So it'll just keep investigating and double clicking on the rows that are still performing poorly, and it'll, just sort of keep adding more and more tweaks to the system prompt until it gets to a point where it's scoring highly. So let me accept this, and then I'll pause Loop, and then we can just run the two prompts side by side, and we can see the difference in the scores. As this is coming in, I can sort of change this to summary. So we can see these different metrics being captured. Let's go back to grid. Cool. So we can see, definitely some improvement on some of these rows, 66%. So yeah, definitely some good improvement that Loop was able to make in just a few turns there. And typically the workflow from here, right? So once you iterate in the playground you make changes, it's all very seamless, right? Because you have that nice UI with immediate feedback from the scores. What you'll want to do is you want to pop this out to its own full experiment. And with what this allows you to do is to compare experiment results across time, right? Because the playground, you only see the eval results that you're running directly in the playground. You can't pull in the results from last week or from 2 months ago. That's what the experiment is for, the experiment page. So we'll change this data set to now be a larger one, all. So this will have easy, medium, and hard questions, and then it'll continue to use the scores that we have here in our playground. So I'll create this, and we can see that it's now pulling out two of these prompts as a full experiment. So if I go to one of them here, so we can see that this is that first basic prompt that we had without any of the edits from loop. And this is all going to be filled in really quickly. Something that is really interesting as well about Braintrust is there's a very unique underlying engine, right, called Brainstore. That's a purpose-built database that's optimized for AI, for the shape of AI, for the schema, and also just the general size of how much is being captured in each span and each trace. And so you'll notice that as you run these evals, even on very, very large data sets, hundreds, thousands of rows, it'll complete quickly, and you'll be able to do full text search really quickly across them. Cool. So we can see sort of the scores, how they came back. Conciseness not doing too good, but the other ones are working well. 82%, pretty good. Let's go to the experiment page. So we can see now the two that we just ran. So I can grab both of them and I can compare them. So that's the benefit, right? It's like you can run these in the past and now pull them into the same UI and compare them directly. So we can see here the change in scores. So the one that we're comparing, that's the one that Loop edited, and we can actually see that it performed a lot better, right, in a lot of these situations. And if we ask Loop, we can also have it analyze this for us. So we can ask which experiment performed the best. It has context of both of the ones you pulled in. You can always go and grab more if you like. So it's that there's no clear winner just because there was some fluctuation across scores. Let's see if it's able to find it. Okay, nice. So yeah, something that you can use here, and it will definitely help as you pull in more experiments or you have larger ones and there's just hundreds of rows to go through. It's you can always click into them and see that full trace, but typically you'll want to have that be automated, right, and speed up your own attention so you can focus on just the ones that are deemed as needing review. Cool. Something else to show here is you can filter this down. Um, you can edit the columns, change the list. You can group by different information as well. So this can be really helpful as you're creating different views. These can all be saved so you can easily come back to them. Great. So I think we just covered a very important workflow in Braintrust. So how you can create data sets, the scores, the prompt, iterate on them in the playground, and then actually create full experiments out of them. And so you can run them on larger data sets, more complex data sets, and use Loop to compare them directly to each other. From here, as this progresses, right? So we've been, if you can remember back to the slide I showed that looked like an upside down pyramid where you start evaling in a very broad way and you start narrowing it down, right? So you go from end-to-end evals to single-turn evals to very granular evals. So that's something that I wanted to show here. Again, this is a RAG use case, so it's retrieving documents, and that retrieval step is very important for the overall quality and performance of this agent. And I want to be able to evaluate it directly. And so what I've done is I've defined scores in my code that I've then ran and sent the eval results to Braintrust. So that's something that's pretty straightforward and easy to do. There's a Braintrust eval command. You point it to one file, boom, all that stuff then automatically gets sent to this nice UI. I've also created a specific RAG eval view, so I can look at all of the specific experiments that ran on this use case, and we can also group this by a specific metadata. So here I can group by model as well. And let me edit this graph. So we can start seeing how these RAG scores are performing across different models. So you can imagine extrapolating this to full leaderboards where you can see your different agent use cases performance across different models. And this will really allow you to have a lot of insight, a lot of signal into what model you should be using in production, which one's performing best, which has the best cost performance trade-off. All of that can be facilitated by these experiments. And you can do the same thing where you grab a few of these experiments, you compare them. Super helpful there. Something that we briefly touched on in the slides is the ability to have a human come in and actually review, right? So you want to always try to align this back to a human. So you can do that by going to the project configurations and creating a human review score, right? So this can be something like, we can say like the assertion score, we can replicate that. And we can provide thumbs up and thumbs down, and we can create this. We can also create another score that's full text. So we can say ideal output and define this. And then when you go back to your experiments and you click into one of them, you'll be able to see this review option in the top right. And if you click into it, you'll now see those scores that you just configured in your settings. And now you can have your team, maybe you have subject matter experts that want to come and manually review some of those experiment results, some of the logs even, right? So this can then lead to you having better LLM judges because they've been aligned to those human scores. Great. And then, finally, as this progresses into production, just to quickly show what that looks like, your logs will be that landing zone for all of your real user interactions. So it'll be a very similar view to the experiments page, but again, this is happening by the user, and all of their feedback, whether that's thumbs up, thumbs down, comments, all of that is getting centralized here. And the same scores that you're using in development, you can then actually run in production. So here I have F1, completeness, factuality, all of those are still running on the production so that I can then, come and filter them down and say, if completeness is below a certain amount, I just want to view those specific user logs. I could grab all of them, add them to a data set. And from there, I have that flywheel loop that we were talking about. If I wanted to filter this down using full text search, also very feasible and fast. And loop is here as well. So we can speed up the process of understanding your logs, what are the popular use cases, what's happening in production. And all of this is to enable that feedback loop. And really, it's about the importance of the process. Once you have a process like this in place, it's a lot easier to incorporate that feedback into your end product with the help of evals and data sets. Cool. So yeah, we covered a lot today. I hope this was interesting and helpful, how you could set this up and run through this yourself. I know we have about 10 minutes left, so I wanted to set up some time to answer some of your questions. Let me add them. Kind of hidden in this UI. Okay, cool. So somebody asked, what is the most counterintuitive lesson you learned about evals? That's a great question. I think there's a few things that come to mind, right? I think it's just it's very counterintuitive to think of an LLM judge being highly effective in grading another LLM, but that's actually been the highest value add that I've heard from companies that are using evals heavily in the wild, is that powerful LLM judges that have been aligned to humans using evals can greatly speed up the process and allow you to ship a lot faster with more confidence. So it just ends up being something that you need to use if you really want to move fast and not break things. Somebody else asked, I'm curious how the space is evolving, and in particular, the level of evaluation needed based on the expected output. If you need the model to be extremely good versus just good enough, can you adjust your eval to meet the need of the feature? Absolutely. So you'll want to balance these two things, right? So depending on your use case, on the specific feature that this LLM is going to be providing outputs for, what is really needed for that? Do you require the most expensive model? Probably not, if it's going to just be, classification or something behind the scenes, right? I think evals can really help you determine where that line is, when you need to jump to that more expensive model or when you can just use something that's cheaper and still equally as effective. Another question around agentic apps. What are important metrics for agentic apps and how should I go about capturing them? Once I have evals metrics, then what? Yeah, so there's a lot of metrics for agents that are really important. I would say that the way to think about it is an agent is a process with lots of intermediate steps, right? And you want to have evals for each of those steps as you start to narrow down your understanding of where the problem is. So you start with end to end and then you start narrowing down, and in that process you're going to create judges and code scores that are specifically focused on those steps. So those will become your metrics, right? um, if you have a use case that doesn't neatly fit into like the 0 to 1 range as a percentage, it's something that can't be normalized, or if it is normalized, it gets rid of a lot of the signal. Then you can use custom metrics in Braintrust, and that can also be uploaded, and you can use that as a way of understanding performance and how things are going. So just another thing to note is that for agents, we oftentimes see people not just rely on these custom scores, but also rely on custom metrics. And then the last question I see here is around what is the simplest way to embed logging/evaluation in backend services and run them when testing the app? Yeah, that's a great question. And I think there's multiple different ways that we solve this problem. Um, the first one to mention is you can wrap your LLM client. So you can use wrap OpenAI, and that will automatically trace all of the inputs and outputs coming from your agents and other use cases. So that's probably like the easiest lift. From there, we oftentimes see people set up their own internal gateway with Braintrust tracing. So as all of their products, all of their projects goes through that internal AI gateway, it will then automatically be traced and appear in Braintrust. And that can be using some of the native SDK primitives. Like we have ways of starting logs, updating spans, like all of this. And you can also integrate with OTel. If you have a framework that's already utilizing OTel, then you can just start pointing it to Braintrust and it'll slurp up all those logs. So yeah, definitely would recommend checking out our documentation as it goes into a lot more detail on the different options there. But yeah, great question. And I think there's options for whatever you're currently running. Yeah, question about latency and cost. So if that's not an issue, and assuming reasonable complexity in the task, should we always use the GPT-5 Pro for LM as a judge? Related, have you found any difference in behavior as LM as a judge across the frontier lab models? For instance, GPT-5, O3, Opus 4.1. Yeah, so good question. So this is about, which model should you be using for the judge? And I think this really depends on what you're using as your task, right? So if um, I think this is still kind of just hearsay. But if you're using an OpenAI model as your task, maybe you'll want to use an OpenAI model as the judge. Um, but this is something that you could also eval, right? What is aligning better to the human outputs, right? Is it something that's in the same model family or not? Something that I have definitely seen give better results is using a more expensive, more powerful model as the judge to evaluate the underlying task. Um, and then in terms of, LLM judges, like I think all these models, they have different characteristics. GPT-5 can sometimes think for a long time, right? And so in your scenario, latency and cost, that's not a thing. But I think the best way to figure that out is just spend some time evaling them, set up a very simple example, and that way you can start comparing directly. Thanks. Yeah, those are all the questions that I have here. It's been great to spend the morning, afternoon with all of you. And yeah, thanks for hanging out with us. Happy to do this. And next time, it'll be a lot of fun as well. Thanks, everyone.